Hello class, hope you are having a great day so far. I am Radhikant, your science tutor. I welcome you all to the wonderful session on structure of atom. I speak English and Hindi. Please feel free to ask any queries in any one of these languages. Let us discuss online tools. So see, in front of your screen, you have chat box option. If you have any queries, you can ask your queries to me by writing your queries in the chat box. Next option is troubleshoot option. So in the troubleshoot option, you can reach out to the team if you face any technical difficulty during the session. So the team will reach out to you to resolve your problem. Next is a raise hand option. So next to the chat box, there's a raise hand option. If you want to talk to me, you can raise your hand. So I will be notified and I will reach out to you to solve your problem. There's audio mute unmute option, using which you can keep yourself mute. You can mute unmute yourself. I request you, all of you, to keep unmuted yourself only when you are talking to me. So during the session, keep muted so that there will be no disturbance of the background noises or sound. There's a video icon next to it. So next video icon option, we have video option. So we encourage all of you to turn on the video option so that we can have the more live interaction with you. So let us begin today's lesson, that is structure of atom. So hope I'm audible and visible to you. Good, great. Now see students, structure of atom is a very important lesson. So why it is important lesson? Because the entire universe is made out of atom. That's why we must know something about the atom. So what are the things we will understand from this chapter? See, in the structure of atom, so we have a historical part, that means discoveries of theories of the atom given by the different scientists. Okay. After the discovery, we will be discussing the concept of valency. Okay. And then structure of atom. Then definitions of atom in terms of atomic number, atomic mass, neutron number, and then isotope, isobar. So let us begin structure of atom. So in the beginning, whether atom is divisible or indivisible, it was not known. But later on, when Democritus, Leucippus, Maharshi Kannada, they discovered atom, and later on modern scientists, when they found out, so atom contains certain particles. So those particles are divisible. But here in this chapter, we have scope for indivisibility. But later on, with the discovery of J.J. Thomson, Rutherford, we understood that the atom can be divided into different parts. So let's see the challenges which the scientists face. So during this division, now see charged particle. When this Benjamin Franklin, one of the scientists, he flew a kite in the sky, and he found that so some electrical energy travels through those particles and reached to it, and he got a shock. That means he got an idea that lightning in the sky has got some electrical properties. That means charges. So that is how. So he came to know that in 19th century. And in the 19th century, other scientists too tried, and they wanted to found out this electron. They had discovered the electron. Like for example, J.J. Thomson discovered electron. E. Goldstein discovered proton. and James Chadwick discovered neutron. So these three fundamental particles. So what are the fundamental particles of atom? Yes, can you tell me? The fundamental particle of atoms are electron, proton, and the neutron. And scientists who discovered. So what is the symbol of electron, proton, and neutron? You can see over here the symbols of electron, proton, and neutron. So these are the symbols of electron, proton, and neutron. So neutron is represented by N symbol. So these are what charged particles. Now J.J. Thomson introduced this atomic model of J.J. Thomson, or we can say watermelon model or plum pudding model. So structure of atom is represented by first time J.J. Thomson. No doubt J.J. Thomson's model nowadays we are not accepting as an atomic model because there are a lot of revision done. But this was the beginning. He introduced a first model. Let's see J.J. Thomson's model, atomic model. Thomson's model of atom. See, Thomson's model of atom indicates that there is a positive field and electrons are embedded in the form of a seed. So he represented this model in this way. But there were certain drawbacks. So Thomson proposed atom consists of positive charge sphere and electrons are embedded into it. Negative and the positive charge gives the total magnitude, that means zero neutral charge to it. But still they have electron. Negative and positive charge are equal in magnitude. That's why they are neutral. Atom as a whole is neutral. Then Rutherford model of atom. So what he did in the second phase, he took atom. He wanted to discover the nucleus. What is exactly? He was not knowing, but he took the gold foil, very thin foil of 1000 atom thick. Then he passed alpha particle through it. Alpha particles are doubly charged, positively charged particle like helium. And what he found, he noticed that when these alpha particles will pass, so he noticed one thing, maximum of the alpha particle pass through this atom. Very few bounce back by wider angle or acute angle. Some of the atom, very few, 1 out of 12,000 atom bounce back in a same path. That is called alpha scattering of alpha particle. Scattering of alpha particle experiment by using gold foil. Now see what are the conclusions of this Rutherford atomic model. He said that there is a positive charge sphere exactly in the center of atom. Then electrons revolve around it, around the nucleus in the circular path. And size of the nucleus is very, very small as compared to the size of atom. 10 raised to the power minus 10 is the size of atom. And 10 raised to the power minus 15 meter is the size of nucleus. It's too small. As if cricket ground, so if you keep a ball of exactly in the middle of the cricket ground, that ball becomes the nucleus, and the huge space from the stadium grandstand to the ball is a space available in the atom. So this is what he compared the atom with the cricket ground. Certain drawbacks were there when Rutherford introduced his model. He said that the atom is unstable, but exactly it is not. Why atom is unstable according to Rutherford? Because when atom revolve around the nucleus, when atom takes around the nucleus, it radiates its energy, it loses its energy and falls finally into the nucleus, making the atom unstable. But entire universe is stable. All the matters are stable. So that's why this idea of Rutherford was rejected, because atom is, later on atom, many scientists, they found that the atom is stable. Bohr atomic model. See, another scientist introduced, and he gave the postulates of the Bohr atomic model. He said that only certain special orbit, that is called the discrete orbit, that means having the fixed energy. So such orbits are present around the nucleus, are inside the atom around the nucleus. Discrete orbit means having packets of energy around the nucleus. While revolving in discrete orbit, the electron do not radiate energy. That means when they jump from one level to the higher level, suppose this is the first level, this is second. So they jump from this level to here. So then they radiate energy. Sometimes they jump from higher level to the lower level when they release the amount of energy. So that means whenever they jump, then only they release energy. Later on, he introduced the concept of energy level. He said that the nucleus, around the nucleus there are orbitals, fixed energy level. He named those energy levels as 1, 2, 3, 4, or shell number like K, L, M, N shell, main shells. And then he introduced the concept of Bohr and Bury, the electronic distribution. That means distribution of electron around the shell. Now see, so who introduced the electronic configuration? The scientists Bohr and Bury. He suggested the electronic configuration by using the formula called 2n square. This we can find out the capacity of shells to occupy electron. Now see, the maximum number of electrons present in a shell is given by, so this formula 2n square. That means first shell is K, K is equal to 1, 1 square is 2, that is 1, 2 into 1 is 2. So 2 electrons are present. That means capacity of a K shell is 2 electrons. Capacity of L shell is 8 electrons and so on. Capacity of N shell is 32 electrons. That means 32 electrons it can occupy. So this is what introduced by the maximum number of electrons that can be accommodated in any of the atom, that is 8, except helium and hydrogen, because they do not have that many number of electrons. This is the reason. Next to it, the electrons are not accommodated in a given shell. So they too have the subshells, right? So this is what, according to Bohr and Bury, we understood the capacity of the electrons. Now, see the distribution of electron in atom. So there are 18 atoms, still argon. So how many number of electrons are present in the first shell? How many number of electrons are present in the second and third and fourth shell? If you check phosphorus, see directly first the hydrogen, 1 electron, helium, 2 electron, lithium, beryllium, boron. Electron number increases 1, 2, 3. In the outermost orbit we are talking now. Carbon 4, nitrogen 5, oxygen 6, fluorine 7, and neon 8. So here the octet is complete. Means what do you mean by octet? Yes, students. Anybody? Good. Yes, please try. Yes, good, great. So this is what octet means, number of electrons are complete. And here helium completes duplet. And again, look at the argon. No doubt, number of electrons, occupying capacity of the third shell is more, but they have only 8 electrons in the outermost orbit. That means most of the many elements, they complete octet in the valence shell. That means 8 electrons in the valence shell. So let's go ahead with another concept of valency. What do you mean by valency? Valency is nothing but the combining capacity, or it is the ability of an atom to donate, to gain, or share electron to fulfill the nearest inert gas electronic configuration. This is the definition of valency, or simple definition, combining capacity. See, let us understand this combining capacity in a simple, with the help of simple example. Suppose we have 2 hands. That means how many hydrogen atoms we can hold? 2. Similarly, oxygen is just like human being, they have 2 hands. And octopus, how many hands? That means for holding octopus with the 8 hand, how many hands of the humans are required? So there are 8 hands required, and for 8 hands, how many humans are required? There are 4 human beings are required to hold the octopus 8 hand. So this is what combining capacity. Okay. Suppose this is 1, valency 1. This is valency 1. So that means combining capacity is 1 only. If suppose there are 2 valency, combining capacity is 2. If there are 3 valency of these 2 atoms separately, combining capacity is 3. And for carbon, 4 combining capacity. Right? So this is what valency is, nothing but the combining capacity of an atom, or it is the ability to share, gain, or accept electrons from the other atom to fulfill the outermost orbit or a valence shell, which will be having a nearest electronic configuration. So this is what. Now look at the chart. It's very important chart. You must know this chart. And here must know portion is that at least 18 elements, atomic masses, atomic number, neutron number. So you must know. Right? Now see, here we have number of electrons. So how can we find out number of neutrons if we know atomic mass and atomic number? So there's a formula. Suppose we have atomic mass. Suppose this is A represented as atomic mass. So what is the atomic mass of aluminium? Is equal to number of neutron. I'm writing with the help of this number of neutron plus here we have number of protons. So we are representing it by Z. So value of a n we can find it out A minus Z. So what is A minus Z? This is A minus Z. So we get the value of n. We get the value of n. So how we are getting the value of n? For example, aluminium. Tell me, what is the atomic mass of aluminium? 27. Atomic number of aluminium? 13. So 27 minus 13 is 14. So number of neutrons in the aluminium is 14. So this way we can find it out number of neutrons present in any of the atom. Like uranium, 235 is the atomic mass and 92 is the atomic number. So this way. Now see how we are going to represent the atom. In valency, before we proceed further, so how will you find out the valency of atom? Suppose, for example, carbon. Carbon has 4 valency. So how many electrons it need to complete the octet? 4. So that's why valence is 4. What is the nitrogen valency? 3. Why 3? Because nitrogen needs 3 more electrons to fulfill the valency. To fulfill the outermost electronic configuration, that is 8 electrons in the valence shell. That's why it accepts 3 more electrons. So we get the valency. So in this way, if you subtract the valence shell electron from the 8 value, you will get the valency of that particular atom, for mostly for non-metal. Okay, and for metals like say beryllium, boron, so their valency is very easy. Whatever number of outermost orbit electron contain, so number of electrons present in the outermost orbit, so that will be equal to its valency. For aluminium, 3 electrons. For magnesium, 2 electrons, 2 valency. For sodium, 1 electron, 1 valency. So how do we represent atom? Do you know any atom can be represented in this way? Look at the atom symbol. X is any atom. On the top, A is shown as a subscript. Z is shown. Z is what? Atomic number. A is atomic mass. And X is any element. Let's move on to the small terminology. It's very important. Atomic number and atomic number and mass number. See, what do you mean by atomic number? Number of protons or electrons present around the nucleus or inside the nucleus. See, if you are talking about the proton, they are present in the nucleus. And if you are talking about electron, they are present around the nucleus, right? So this is what number of atomic number. Atomic number, by definition, it is denoted by a Z letter, and it is a number of protons present around, means inside the nucleus, and number of electrons present around the nucleus is for atomic number. How will you find out mass number? You know, according to Rutherford's atomic model, the entire mass of the nucleus is concentrated in the center. And the mass of the nucleus consists of two parts. One is here like proton and another is neutron. So this combined masses forms or gives the mass of a particular atom. For example, carbon, 6 number of protons, 6 number of neutrons. So total mass of the carbon is 12. So you can look at the chart. So these masses are important. So just go through this chart. Yes, can you see? Can you read out? Yes, any one of you? Yes, hydrogen, helium, lithium, beryllium. See the number of masses. Hydrogen is 1, helium is 2. Helium mass is 4. Atomic number is 2. Lithium is 3. Atomic mass is 7. Beryllium 9. Boron, atomic masses. You can see atomic masses of boron. You can see boron. Atomic mass is not given. I am telling you. Atomic number is given. Atomic mass either double or it depends upon the number of neutrons. It's addition of number of neutrons plus protons. So oxygen 16, fluorine 19, 9 plus 10. Neon, it is 20. Sodium 12 plus 11, that is 23. Magnesium 24. Aluminium 27, silicon 28, phosphorus 31, sulfur 32, fluorine 35.5. Here is a decimal. Let's see, this is what chart you need to learn this chart so that you will understand the chemistry. Basically, this is very important chart. Now here you understood the mass number. Now see further. Isotopes and isobar. Isotopes and isobar. See, what do you mean by isotopes? So atoms of the same element, having same atomic number and different mass number. For example, hydrogen. There are 3 isotopes of hydrogen. One is hydrogen, another is deuterium, and a third one is tritium. So how many number of neutrons are present in the first isotope hydrogen? Yes. Can you guess the number of neutrons? No. Yes, very good. There are no neutrons in the hydrogen, first hydrogen. But deuterium contains 1 neutron, that's why mass is 2. And tritium contains 2 neutrons, 1 proton, that's why mass is 3. So these are the heavy water. That means suppose if you take water H2O, D2O and T2O. So heavy water, and mostly heavy waters are used in nuclear power plant. Carbon isotope, carbon, there are 2 isotopes, carbon 12, carbon 14. Chlorine, there are 2 isotopes, chlorine 35, chlorine 37. Now, the question arises, if the masses of isotopes of chlorine is 35 and 37, its average is coming something different, 36. But if you see the mass of chlorine, so it is coming different. Why it is so? It is 35.5. See, in the atmosphere, chlorine is present in different percentage. 35 mass of the chlorine is present, 75%, 37 mass of the chlorine. In the atmosphere, its a part is only 25%. That's why 25% of 37 and 75% of 35. This calculation is coming around 35.5. That's why it has got fractional mass. It is also true with some other elements like sodium, 22.99 mass. So in this way, we understood over here the average atomic mass. It depends upon the percentage. Okay. Now, what are the applications of isotope? Isotopes are very applicable because uranium's isotope is used in the nuclear reactor for the production of energy. Some isotopes are used in medical industry for the treatment of a cancer. Cobalt-60. And isotopes of iodine, it is helpful in treating the goiter-like disease. Sodium isotopes are used in understanding the flow of blood. So there are many isotopes that are useful even in our day-to-day life for identifying the ages even. We can find out the age of the ancient people by using the carbon dating technique. This you will learn in the higher classes. Now let's see isobar. Isobar is what? It is the atoms of a different element. For example, argon, krypton, and potassium having same atomic masses but different atomic number. They are the elements of different. They are the atoms of a different element. They are different. That is why. So they have different masses. They are kept in different groups, whereas isotopes are kept in the same group, like chlorine 35, chlorine 37. They are where they are present in the periodic table. In the periodic table, their location is similar. There is no difference in the location. So this is called isobar. What is the example of isobar? Yes, anybody? Yeah, good. Argon. What is the atomic number of argon? Argon atomic number is 18, but what is its atomic mass? It is 40. Then potassium. What is the mass of potassium? It's 40 again. And atomic number is 19. If you talk about calcium, what is its atomic number? 20. Atomic mass? 40. So these argon, potassium, and calcium, they are the isobars. That means they have different neutron number. Neutron number is different, but though they have different number of neutron, but if you calculate their total, you will get the same total. That is why this isobars we discuss. Students, we have seen in this lesson from the beginning, atoms, structure of atom. That is the discovery of electron, that means charged particle of the matter. So which were discovered by the Benjamin Franklin, and later on J.J. Thomson proved that the electrons are negatively charged. Goldstein and the James Chadwick. So the three fundamental particles of the atom were discovered by this, right? Then atomic theories were put forward by the J.J. Thomson, Rutherford, and Bohr atomic model, which we are discuss over here. After the atomic models, we understood that the fundamental particles are present. Those fundamental particles play a very important role. And we understood the atom is divisible into further fundamental sub-particles like electron, proton, and the neutron. Then we studied the drawbacks of some of the scientists, electronic configuration. After electronic configuration given by the Bohr and Bury. So we studied the isobars, isotopes, and the valency. So this is the overall view of this lesson, summary of the lesson. So hope you guys understood this lesson, structure of atom. Study well, prepare all the questions connected to this lesson. All the topics in this lesson are very important. In case of a doubt, you can reach out to me. So hope this session you enjoyed. It was a wonderful session. In case of any doubt, you can reach out to me through our forum or various platforms. So thank you all. Have a nice day, wonderful day. Thank you. Bye. Bye, students. Bye.